I'll talk about data insights from nutrition to industrial automation. Now, this is typically, this is a 12-week lecture, but I tried to condense it into, I think 15 minutes, so this should, okay, this should be fine. And here's here's the thing. Right? This is my abstract. You don't need to read it. It's for those people who look at it afterwards. But some of you will know this, right? Who knows this? Oh, it's getting worse every year. This is really problematic. So this is Mastodon. This is one of the largest social networks out there. It's the 9th largest social network on the planet. No one knows it. Trump copied it recently. So Trump copied the source code of this thing for his Truth Social thing. Then they figured out that this is under a copyleft license, so they were sued, and then they had to, well, and so on. So this is Mastodon. Most people know this though. Recently we saw this nice GDPR thing coming up, right? And GDPR has this interesting provision, Article 20, the right to data portability. In exercising his or her right to data portability pursuant to paragraph 1, the data subject shall have the right to have the personal data transmitted directly from one controller to another where technically feasible. This is rather big, right? And I love it what you guys said before, that data sharing is coming up also in the industry. Wonderful. So this means that we are breaking data silos, right? So we're creating interoperability, data interoperability in this case. And with a few colleagues, we recently went further. We call this the right to customization of services. We argue that the current legal basis also allows for consumers to determine aspects of the processing of data, even though the processing is not under their control. Today, this was featured in a small newspaper and 2 small newspapers in Austria, I'm saying, in Switzerland. I will show you how we are utilizing this currently in digital health. Okay. So what we are doing there, the project is called Food Coach. It's not a product yet, it's only a PhD thesis at the moment. But what we're trying to do here is we're trying to have an automated evaluation of the health impact of individual shopping baskets. Okay, so you go shop and then we evaluate your shopping basket and then we tell you, hey, could you not buy a little less sweets from packaged foods, something like this, right? And this looks like this. So this is a prototype that we were doing last year. This gives you your average Nutri-Score for your, so this is 2021. This gives you your Nutri-Scores for your shopping baskets in the past, right? And so then you can take informed decisions, insights, right? So first we make this data accessible for users, and then we design and evaluate dietary interventions. So we tell the user, hey, why not do that, right? And now, just 2 weeks ago, we started a collaboration with Inselspital in Bern, where we're trying to automate dietary counseling based on this data. So ideally, a for-free dietary counsel for every person in Switzerland for free. That would be nice, right? And here's one example that we did last year. This was the Future Me trial. What we did here is we used the Future Me avatar. So we used an avatar of the person who was using this application, but we let this avatar age by 20 years. Okay, so this is one of our co-authors, aged by 20 years. And then the avatar predicts what will happen to her heart in this case if she keeps on buying stuff like this, right? I'll go into the limitations in a minute, of course. And this is, of course, we need to collaborate across marketing and computer science and so on, right? Now, where do we get the data from, right? And obviously, having talked about the right to data portability before, we get the data from here, right? And in Switzerland, we are blessed because in Switzerland, we basically have a duopoly in grocery shopping. The duopoly is formed by Migros and by Coop. Both of these have loyalty cards, and about 80% of the Swiss population has one of these loyalty cards. So this is massive. This is a bit like this thing that was introduced in Österreich, this EU stuff, right, recently. So the point is that the users can give us access to their data, can donate their data in that sense, and then they get back actionable insights from their data from us, right? Now, so we did this Future Me trial. We were able to show that we can increase the intrinsic motivation of people to eat healthily through something like this, right? Which is one of the most important predictors for actually eating healthily. Okay, so this intrinsic motivation thing. So we get user consent, then we enrich this through a food composition database. We have a database of about 45,000 Swiss products that via link like this. So this is this barilla, pesto, basilico, and rucola. And if you go to this link and have the right credentials, then you get the nutrients that are in there, macronutrients and food category. Okay. We also get the GTIN, the Global Trade Identification Number, because identification is everything in this case, right? And then we compute health indicators. We provision health interventions like these, right? We create health interventions. And then this is also currently being used by human diet coaches, and our goal is in a few months to have this automated diet coaching that I was introducing before. However, we can do funnier stuff with this. So down here is the limitations. The limitations are awful, right? But they are discussed in the paper. We hope that we get rid of them. So what we now do with this, and this will bring me on my road towards industrial automation now. Last year we did this thing over here. So this is a screenshot from the Produkte Mikro shop, so from the actual Mikro online store, grocery online store. And what we did is we enriched this with a Nutri-Score, right? So we did client-side modding. All of you have ad blockers, right, on your machines. We basically did ad blocking, just that we didn't remove stuff, but we added stuff. Right? This is fine. This is legally fine because it could be applied to every company. So we're not singling out a company. So this can be done, and it's on the client side, so it's under the control of the client, which is beautiful. This is also why we call it guerrilla modding. Okay, and we recently published this in Nature Machine Intelligence. This was quite cool. So because we were able to show that if we subject people to this instead of this, they shop significantly healthier. Look at that, right? So I could roll out an intervention at population scale that makes people healthier. This is cool, and it's even under control of the user. And then we tried to apply this to sustainability. So we created this thing down here, Better Planet. This thing is not a Nutri-Score, but it's the average CO2 score of your shopping baskets, right? So we created an estimation model of how much CO2 your shopping basket generates, and then we created these things down here. You can then see that the typical Swiss person generates 16% of their CO2 from hard cheese, right? Which makes sense, of course. And then we come to these very funny metrics, and I love this metric. So this is about Selection Kartoffeln Raclette, so raclette, obviously. Our main metric here is grams of CO2 per kilocalorie, right? So I pay with CO2 for the energy I get. I like this. It kind of closes the cycle. And this is well, this. I love this stuff. You can tell, right? I love this stuff. So then now how this looks for users, right? Basically, so our model we are inspired by ecological psychology. So the user basically looks at this thing, right? And then the user will say, oh, this is eatable, this is buyable, right? The button here, and this is reduce healthable also a little bit, right? And if we now increase the salience of these markers, we increase the reduce healthable. Do you see what I'm saying? So like this chair is basically sittable, right? Because it's about the size of my behind. Right, that's why. So if I could go a bit more extreme, this has lots of saturated fats, I would increase the reduced healthable, maybe the person wouldn't buy this anymore, which is also why Migros doesn't want us to do the server-sided, right? Well, Migros would like us to do, but their suppliers don't. Right? So then, some of you will know affordance theory, especially the people in UX design, UI design. A door like this affords to me pulling, right? A door like this affords to me pushing. A door like this affords to me turning the knob, and I don't need any other explanation about this. Okay, this is pretty powerful. A flat surface suggests pushing, therefore I put a label pull, right? This is what I need to do in these cases. And a similar principle is happening on the web. Okay, on the web, if I look at Google, and here I'm rendering Google without hypermedia. So this is Google, but no hypermedia on it. It's basically unusable, right? However, I could still use it, right? I could put up here google.com, I could go to the documentation, then I could manually enter my search term. Clear, right? I just don't have the hypermedia control. I just cannot click, the rest is the same. This is actually what comes out when I click on Google. Now, the realization is that these affordances are quite similar. In the real world, sittable, and on the web, clickable, feeling luckyable, right? Stuff like this. So how can we now exploit this for making machines more autonomous? Well, on the web, we don't realize it most times, but we rely on affordances with text, images, and other media to navigate the web, right? And the cool thing about the web is that we take these decisions at runtime. We are not hard-coded against the web, right? I enter into Google and then I click, 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 click. So if anything changes on the path, I don't notice. Do you see? Because this is the central point of this thing, right? So we automatically adapt when the web application changes. This is massive. This is basically why the web is so successful. Right? This is like the core reason why the web is so successful, because we can decouple our own browser from the web application. Google can change, and my browser stays the same. Right? They're decoupled, so they can evolve independently. Now, how could we do this? This mechanism is called HyperOS, by the way. Hypermedia is the engine of application state. This simplifies access to and mashing up of data on the web, and it's very important for machines, and I'll show you this in the last 2 minutes of my talk, right? So because this enables automatic adaptation at runtime, just like we adapt, just like our browsers in that sense adapt to changing web applications, machines could adapt when they use each other's services, when one robot uses another robot's service, okay? So how can we exploit this? Well, to permit it, we need something like standardized structured metadata. And a few years ago, this came out of a few PhD theses at ETH in the 2010s, so 2010 through 2014. What we are doing is we are adding metadata, semantic structured metadata to machines that says this is a robot, it has a 62 center point position, it provides move actions, it can notify, and it was manufactured by some company. And then we put this into something that we recently standardized in the W3C, which we call a Web of Things thing description. Okay? And this thing description acts in the same way as hypermedia acts for people. And I'll show you one of these in a minute. Okay? It contains information about what I can do with a thing, and that information contains protocol bridges, which with protocols we like in research, and then with protocols that you like in industry, or that many of you like in industry. Right? So this fits, and the first products are now on the market. This is the Siemens Desigo building automation system. This is what this looks like. Right? So here's one of those files. It doesn't look terribly consumable by people, right? But it's not meant for people. This is structured metadata for machines, right? This enables machines to browse these structures. And here is one of our robots. And what we are now doing is basically, so many of you will know this, of course, right? So here's one of our robots. Feel free to access it, right? This is our students are playing with this every day. So down here you will see that this thing is basically mapped into an HTTP interface, and you can also, so really feel free to use it, right? You can also look at the live stream from our lab right now. At nights there's a control for the lamps to switch them on, so that you can use this. But what we are now doing, and this will bring me to the end, what we are now doing is that we are bringing machines fully into the web, right? Not just web with things. See what I mean? Not just a web API to a machine, but a hypermedia API, the thing that we use for clicking on the web, that for a machine. And what this means is that our machines are suddenly easily discoverable by people, that I can integrate them just like I'm integrating websites. For instance, through a search engine, I can make my things searchable, and that I can discover and use them by other software agents. This down here is the biggest one from our perspective. Machines can autonomously make use of each other. So all useful mechanisms that we know from the web, we can now apply to devices, services, and their data. And this I find pretty cool. So I think that we're going from integrated cyber-physical systems, where we have the firmware packed into this thing, right? I buy the washing machine, all the software is on it, and I'm coming from there to some unbundling of the services of this device. So I'm putting low-level APIs, and then I'm putting the application software that runs these things out here. That makes me able to mesh these things up, right? Because no meaningful program is running on this device anymore. Everything is out here. That brings me to the end. We recently introduced computer science programs at HSG because the world realizes that computer science is pretty central to strategic decision making, right? So a match made in heaven. Down here, computer science. Up here, management aspects. So we are combining this. We started a Master of Science last year. We are starting a Bachelor of Science this year. You or your children can currently enroll until the end of March. That was it. Thanks a bunch.